Jerry just returned from a cross-country trip. The trip was 3,000 miles from his home, and his total time in the airplane for the round trip was 11 hours. If the plane was flying at a rate of 550 miles per hour, what was the speed of the jet stream? Now, for this exercise, we're going to use uniform motion ideas. We know that distance, generally speaking, we know that distance is equal to rate times time. Now the issue is we have two trips. We have, because it's a round trip, we have a trip going toward the destination and then coming back home. And we know that distance each time was 3,000 miles. But we don't know the specific rates or the specific times. So let's sort of think about this. Let's say going away from home, let's assume for a moment that that was with the wind, with the jet stream. So if it's with the wind is helping. We then know that the distance was 3,000 miles. And let's say that the rate of the jet stream, let's say the speed of the jet stream, let's call that x. Let's call the speed of the jet stream x. So then, the distance going away from home was 3,000, and the rate, well, the plane could fly at 550 miles per hour on its own, but we also had the jet stream helping. So therefore the rate was 550 plus x. And we don't know how long it took. So let's just call that time, let's just call that t1. And so now notice then, I can divide through by 550 plus x, and then I have t1 is 3,000 over 550 plus x. Now going toward home, right, so now coming back, well, that would be against the jet stream. So now that wind is hurting us. It's making us go slower. Again, using distance equals rate times time, now we have 3,000 is equal to 550 minus x. And again, we don't know that time coming back, right? We don't know the time as we're going toward home, so let's just call it t2. Well, then t2 is equal to 3,000 over 550 minus x. But we do know that the total time for the round trip, right, the total time in the airplane was 11 hours. So we know that t1 plus t2 must equal 11. The total time must equal 11. And so then t1, 3,000 over 550 plus x, plus t2, 3,000 over 550 minus x, must equal 11. Here's an equation we can use to solve this problem where x is the speed of the jet stream. So let's solve for x. 3,000 over 550 plus x plus 3,000 over 550 minus x equals 11. All right, first thing I'm going to do is clear the fractions. I'm not good at solving equations with fractions, so what I'll do instead is I'll clear the fractions. I'll multiply both sides of the equation by the least common denominator, which is, let's multiply by the LCD, which is 550 plus x times 550 minus x. And if we do this, we now have 3,000 times 550 minus x plus 3,000 times 550 plus x is equal to 11 times 550 plus x times 550 minus x. Now notice that the 550 plus x times 550 minus x is a special form. That's a difference of squares. That's 550 square minus x square. And so that's 302,500 minus x squared, once we simplify that. And we still have to multiply that by 11. All right, so let's simplify this equation some, get it into a form that's a little bit easier to work with. 3,000 times 550, using a calculator here in the background, that's 1,650,000. So I have 1,650,000 minus 3,000x, and then I have 3,000 times 550 plus x, so that's 1,650,000 plus 3,000x. And then applying a distributive property on the right, taking 11 times the 302,500, that's 3,327,500 minus 11x squared. And so I see a quadratic equation here, but let's see, some nice things happen. I have a minus 3,000x and a plus 3,000x, so that's 0. And let's see, I have that 1,650,000, I have two of those, so let's add those together. So that's 3,300,000 is equal to 3,327,500 minus 11x squared. And so now I look at this equation, and this is quadratic, and I see no x term. I just see an x squared term, so I can use the square root property, but I now have to isolate. I have to get this x squared by itself first before I apply the square root property. So let's subtract the 3,327,500 from both sides. All right, so going through that subtraction, I get negative 27,500 on the left. And on the right, I now have negative 11x squared. And let's divide through by negative 11. And I find that x squared is 2,500. Applying the square root property, then x would equal the positive or negative square root of 2,500. So doing that in the background, I find that x is positive or negative 50. So then my answer was, and let's remember, what was the original question? What was the speed of the jet stream? We called the speed of the jet stream x, right? We called the speed of the jet stream x, and we found through our work that x was positive or negative 50, and so from that we can conclude that the speed of the jet stream is 50 miles per hour.